Let's have another problem applying Newton's laws. As shown in the figure, we have a 5 kilogram block on top of a horizontal surface with a coefficient of friction equal to 0.02 is connected to another 3 kilogram block by means of a string passing through a frictionless pulley. When the system is released, determine the acceleration of the given blocks. But before answering the problem, let's have a quick review of what is a friction force. Friction is also force, which is always in opposite to the direction of motion, and it acts between surfaces, or this is classified as a contact force. And friction force is directly proportional to the normal force. What is a normal force? It is the force responsible for the pressing of the two surfaces together. When we say friction is directly proportional to the normal force, meaning the greater the normal force, the greater the friction force. And another thing, friction also is affected by the nature of the surface in contact, of the surfaces in contact. So we can write F, or friction force, into equation by considering the nature of the surface as a constant, that is the mu. If mu is less, meaning the surface is smooth, and if mu is great, meaning the surface is rough, then mu n. So meaning we have now the equation F mu n, where mu is the coefficient of friction. But then we can also classify friction force or friction forces as kinetic friction, static friction, or the rolling friction. Kinetic friction, this type of friction force, or we can label this as if K, occur between surfaces having relative motion. So if it is in motion, and static friction if the friction that will act between surfaces at rest. So let's label this as Fs, or the rolling friction, the friction force which occur between rollers or wheels and the like. Specifically, if it is kinetic friction, we have if K, this is equal to mu K, or this mu K is the coefficient of kinetic friction times the normal force. And also for static friction, this is equal to mu S, static coefficient of static friction, n. And of course, the Fr, the mu coefficient of rolling friction times the n. So we have in here the basic concept regarding friction force. So let's answer the problem. Our first step in solving the problem, let's label our 5 kilogram as our M1 and our M2 equal to 3 kilograms. So the two masses are being connected by a string, and then it passes to frictionless pulley. Therefore, if it is frictionless, the tension exerted by the string in here is equal to the tension in here. And let's do the free body diagram of the two masses. The mass 1, here we have, of course, the weight, the pull of gravity equal to the weight of our mass 1, or let's label this as W1. And we have the tension, since we have a rope, so let's label this as our T1 in this direction. And we have surface, so we have the friction force and the normal force exerted by the surface. The normal force perpendicular to the surface in contact, and then the friction force, of course, assuming that our mass 1 will move along horizontal in the right direction. So the friction force will be towards the left, assuming that our mass 1 will move towards the right. And then for the free body diagram of our M2, we only have two forces that act on it. W2, the weight or the force of gravity pulling the mass 2, and the tension 2. But then take note that our mass 2 will move downwards. So our acceleration will be directed downwards. And our two masses are connected with a string. And since they move with the same speed, of course, and they will accelerate the same speed or the same magnitude. So our A1 magnitude should be equal to A2 in magnitude. So we can just label this as RA, but they differ in direction. So they are only equal in magnitude. And since our pulley is assumed to be frictionless, so our T1 will also have the same magnitude with our T2, or we can label this as simply T. So our aim is to solve for the magnitude of the acceleration. So let's start with M1. Consider the free body diagram of M1. Summation of forces along X is equal to, there is an acceleration. So this is equal to M1A. And our A1 is positive, or simply A, since A1 is equal to A2 or A. And let's determine the forces acting on our M1. So we have the T1 positive, or simply T, minus our negative direction F towards left, and no more. Since N is vertical and W1 is along vertical, so we only have these two forces, and this is equal to our M1A. So this is our first equation, and since we do not have T, value of T, and value of F, we cannot proceed. How about considering the summation of forces along vertical? So summation of force along Y, this is equal to, is it MA or 0? Since there is no motion along vertical, so at rest with respect to our vertical axis. So this is first law, 0. And so what are the forces? We only have normal force upward minus the downward weight, or weight 1, and this is equal to 0. Therefore, our normal force is just equal to, weight is equal to mass and gravity. So this is equal to M1G. So we have now our equation for N. So substituting this to our first equation, we have T minus F is mu N. Mu N equals M1A, or this is equal to T minus mu, what is our N? N is just equal to M1G equals M1A. So our tension is equal to mu M1G plus M1A. So since we do not have the tension and we do not have the acceleration, we cannot solve anything in here. So we need another equation to solve for the two unknowns. So how about mass 2? So let's consider now the FBD of mass 2. So we have in here summation of force along Y. Since there's no forces acting along horizontal, so we only have summation of force along Y. This is equal to, of course, there is acceleration along vertical and specifically towards negative. So M2A directed downwards. T, what are the forces? We have the T2, or simply T, minus W2 equals negative M2A. So we have T equals W2 minus M2A. So, or T is just equal to M2G minus M2A. So we have here another equation. If this is our equation 1, and this is our equation number 2. So solving for the two unknowns in two equations is now possible. So we can now solve. Since the two equations, equation 1 and 2 are all tensions, so we can write mu M1G plus M1A. this is also equal to m2g minus m2a. So grouping all the acceleration to the left side, so we have m1a, transposing the m2a here becomes positive m2a, and copying m2g and transferring or transpose the left side term to the right side. So we have negative mu m1g. So solving for A, we have m1 plus m2, and then factor out g, m2 minus mu m1, and then A therefore is equal to g m2 minus mu m1 all over m1 plus m2. Plugging in the values, g is equal to 90.8 meter per second squared, and then m2 is 3 kilograms, and then minus, this is, the mu is 0.02, and then m1 is 5 kilograms, all over m1 is 5 kilograms plus 3 kilograms. So our acceleration is equal to 3.55 meter per second squared. So the kilogram cancelled out. So we are left with this unit. And this is the unit for acceleration. So it is positive, meaning our assumption that mass 1 will move to the right, and then our mass 2 will move downward is true. We can also solve for the tension. Example, if you want to know what's the magnitude of your tension, you can just plug in this value for our acceleration, either in this equation, equation 2, or equation 1 to solve for the tension.